There's some indication that the Chinese began trying to make food safer somewhere around 1100. In the last 60 days, 28 people have died from listeria in melons. In the spring of this year, 4 people in Germany died from E. coli contamination. So I think that what we can all take from that is there's lots of room for improvement since 1100. This technology can detect multiple pathogens in a single test in less than 30 minutes, reliably and all the time.
The current cassette is a 5-chamber cassette. The cassette is set up so that one of these chambers is something called a negative control. A second of the chambers is for a positive control. The remaining 3 chambers, in this case, could be for E. coli, for salmonella, and for listeria. A single sample would be processed, entered into each of these chambers. A vacuum would be applied to the backside. The sample would be drawn into these chambers, and within the chambers, a liquid crystal matrix aligns. If there are no aggregates, no distortions of liquid crystal, no light moves across. If there are clumps of bacteria caused by that specific antibody, they twist the light, a process called birefringence, and that some of that twisted light now can move across the second top polarizer. The effect are a series of spots of light. It could be visualized as a pinhole of light. And essentially a photodetector on the top of the unit simply senses the spots of light, those pinholes, as an indication of bacteria or virus of interest being identified in that chamber.
You know, in the 1950s, a member of our chemistry faculty became interested in a curious class of substances. They flowed like liquids, but shared the properties of crystals. Glenn Brown believed that these liquid crystals held great scientific potential. The rest, as they say, is history and a multi-billion-dollar industry worldwide. And it was Kent State's James Ferguson who invented the liquid crystal display in 1967. Now, because of our partnership with Crystal Diagnostics, Kent State has another opportunity to share research with the world. In this case, it's taken the form of technology that can help eliminate pathogens in food.
You know, at NeoMed, we conduct research that makes an impact on patients, on people. And this product is a tremendous example of the excellent work that our researchers are doing. So when you think about it, it's hard to imagine that there were 48 million foodborne illnesses last year, 48 million. That's a big problem. If a medical university should do anything, it ought to work on problems like that and hopefully solve them, which I think in this case we have.
The ultimate advantage of this is a much safer environment. And this particular technology acts on all aspects of that environment. The food we eat, the food we shouldn't have ate, the contaminated environment, the safety of our pets. We believe this technology will have a profound effect on the safety of our environment.